everyone. So today's goal is 61 to 85 questions. Let's start. 61. A stone is thrown vertically upwards with an initial velocity of 40 meter per second. G equal to 10 meter per second square. What is the net displacement and the total distance covered by the stone when it returns to the earth? So my dear children, here a stone is thrown vertically upwards with an initial velocity of 40 meter per second. So here when it is going upward, its speed decrease. After reaching the maximum height, its speed becomes 0. Okay, my dear. Then it ends to its starting point. While it is coming down, its speed increases and it strikes the ground with the same speed, that is 40 meter per second. Clear? Suppose this is A point. Okay, right. So what is the net displacement? So what is the net displacement? Displacement means, already we know very well, displacement means change in position. Change in position. Change in position. That means final position minus initial position. Here final position is A and initial position is also A. Initial position is also A. So there is no change in position. If there is no change in position, displacement is equal to 0. So in option 1 0 is there, in option 2 also 0 is there. Then go to total distance covered by the stone when it reaches to the earth. So calculate the distance travel. So first calculate distance here. So your initial velocity is there, final velocity is there. So use third equation of motion, v square minus u square equal to 2as. Final velocity is 0 minus your initial velocity is 40. That is 40 whole square is equal to into, in the place of a here g value is given 10. S is displacement, or in this situation S is distance. So S. So here G is minus 10 meter per second square. This minus this one gets cancelled. So this is 40 into 40 is equal to 2 into 10, that is 20 into S. 21 the 22 the. So distance is equal to 80 meter. So in the upward journey the distance is 80 meter. In the downward journey the distance is 80 meter. Distance is a scalar quantity. So total distance, then total distance covered by the stone, total distance is equal to 80 meter plus 80 meter, that is equal to 160 meter. So 160 meter. So option 2 is the right answer. Displacement is 0 meter, total distance is 160 meter. Then here 60-second question. 60-second question. A stone is allowed to fall from the top of a tower 100 meter high, and at the same time another stone is projected vertically upwards from the ground with a velocity of 25 meter per second. When and where the two stones will meet? So a stone is allowed to fall from the top of a tower. So my dear children, consider it is a tower. So one stone is A. So it is allowed to fall from the top of a tower. The tower height is given, it is 100 meter high, and at the same time another stone is projected vertically upwards. Here suppose that is B stone, it is projected vertically upwards with a velocity of 25 meter per second. So it is fall means stone A velocity is 0. So when and where the two stones will meet? When and where the two stones will meet? So we have to calculate time and height. Time and height. So here suppose at this point the two stones will meet. From top, suppose this distance is x. From down, this is equal to 100 minus x. Okay. So calculate A stone, A stone, we know very well, use second equation of motion here, that is S is equal to ut plus half AD square for A stone and for B stone. So for A stone, in the place of S, the distance traveled is X, U is equal to 0, then it is equal to half G T square. For B, so B, how much distance the stone B traveled, that is equal to 100 minus X is equal to initial velocity is 25 into time t, this is minus half g t square, minus half gt square. So in the place of x, that is 100 minus, in the place of x write minus half gt square, that is equal to 25t minus half gt square. Minus half gt square minus gets cancelled, then t is equal to 100 by 25, that is equal to 4 seconds. That is equal to 4 seconds. That means the two stones will meet above the ground after 4 seconds. Then calculate height. So from the ground, suppose from the ground, from the ground, from the ground or above the ground. So in the x equal to half gt square. X equal to half gt square, right here x equal to half, in the place of g10, t square time 4 seconds. Square means 4 into 4. That is 2 1 ja, 2 2 ja, that is equal to 80 meter. So this is 80 meter. This is 80 meter means this is 20 meter. That means the two stones will meet at a height of 20 meter above the ground after 4 seconds. So option 1 is the right answer. Option 1 is the right answer. 63 question. An object is thrown vertically upward at 35 meter per second. Taking g equal to 10 meter per second square. The velocity of the object 5 seconds later is. So my dear children, an object is thrown vertically upward with a 35 meter per second. So first calculate what is the time taken by the object to reach the maximum height. So that is the time taken to reach the maximum height. That means when final velocity becomes 0. This time we can call it as the time of ascent. Already we know time of ascent formula is u by g. So u is equal to 35 meter per second. G is equal to 10. That is equal to 3.5 seconds. But here calculate the velocity of object after 5 seconds. After 5 seconds means time taken to reach the maximum height is 3.5 seconds. After reaching the maximum height, its final velocity becomes 0. Then it will return to its starting point. While it is coming down, its initial velocity is equal to 0. So 3.5 and 1.5. This is the total time 5 seconds. So after 1.5 seconds, calculate the velocity. That is, use first equation of motion v equal to u plus at. Here u equal to 0. A is equal to g, that is g. In the place of g, write 10 meter per second square. Actually, this is minus 10 meter per second square. Time is 1.5 second. 1.5 seconds. So 1.5 seconds, and this velocity the downward direction. Remember, this is also taken as minus. So minus minus gets cancelled. V is equal to 15 meter per second downwards. So V is equal to 15 meter per second downwards. So option 1 is the right answer. Next here, 64th question. A stone is released from a balloon that is descending at a constant speed of 10 meter per second. Here a stone is released from a balloon. Consider this is a balloon. So the balloon constant speed is 10 meter per second and it is descending, means downwards. So a stone is released from it. So the stone initial speed is also 10 meter per second downwards. 10 meter per second downwards. Neglecting air resistance, after 20 seconds the speed of the stone is. After 20 seconds the speed of the stone is. So here velocity is in the downward direction. If velocity upward direction is taken as positive and velocity downward direction is taken as negative. use first equation of motion, that is equal to v equal to u plus at. Here final speed, that is minus v, and initial velocity also the domain, that is minus u, a g minus g into t. Okay, now right, so this is minus v is equal to minus 10, that is minus in the place of g 10 into time 20 seconds, that is equal to minus 10 minus 200, that is equal to minus 210 meter per second. So minus 210 meter per second. So minus minus gets cancelled. Then V is equal to 210 meter per second. But here if you take G value 10, the answer is 210 meter per second. But here G value is given in 9.8 meter per second. So same in the same equation, V equal to U plus AT. If you substitute in the place of G 9.8 meter per second square, that is minus V minus U minus G into T, that is minus V minus 10, in the place of G write 9.8 into 20. So 0.0 gets cancelled, that is minus 10 minus 196, that is equal to minus 206 meter per second, that is equal to 206 meter per second. So option 3 is the right answer. Let next here 65th question. A stone is dropped from the top of a tower 5 meter high into a pond of water at the base of the tower. So consider it is a tower. It is a tower of height 500 meter. Of height 500 meter. So at the base of the tower, here water is there. Okay. When a stone is dropped means u equal to 0. So when it strikes, when the stone strikes the surface of, this is the initial position, this is the initial position, this is the final position. If displacement is below the initial position, that is taken as negative. So here for stone use second equation of motion, that is s equal to ut plus half at square. Here u is 0, displacement is minus 500, so this is minus half in the place of ag, that is t square. So minus minus gets cancelled, so that is a half in the place of g write 10 t square. So this is 500, so 0 0 gets cancelled, if 2 comes this way, 2 into 50, that is 100 is equal to t square. From this t is equal to 10 seconds. The time taken by the stone to reach the surface of water is 10 seconds. So when stone strikes the surface of water, the sound is here. Sound is coming up. So after how much time the splash here at the top? This is sound. So time taken by the sound to reach the top. So calculate for sound. Here speed of sound is constant. So constant means use s equal to ut. From this t is equal to s by u. Here s means distance traveled by the sound. The sound traveled a distance of 500 meter by u means speed of sound, that is 340 meter per second. 0 0 gets cancelled. 225 ja, 270 ja. 25 by 17, that is equal to 1.4 seconds. This is a sound time taken by stem. Then total time is equal to t1 plus t2, that is equal to 10 seconds plus 1.4 seconds, that is equal to 11.47 seconds. This is the total time. That means this after this time the splash of here at the top. So option 1 is the right answer. Next question. Next question. 66th question. If the time of fall of two objects are in the ratio 1:2, then find the ratio of heights from which they fall. If the time of fall of two objects, consider one object is A, another object is B. Here for A object the time taken is T1, for B object the time taken is T2. Suppose this height is H1, this height is H2. Already we know very well, if distance is given and time is given, use second equation of motion, s equal to ut plus half at square. So time of fall of objects. So consider initial velocity of A is 0, initial velocity of B is 0. Then S is equal to half g t square. So use this equation for object A. For object A, that is SA is equal to 1 by 2 g t1 square. T1 square here. So in the place of S, write H, suppose H, this is H1. Then H2 is equal to 1 by 2 G T2 square. Right. So 1 by 2 G 1 by 2 gets cancelled. Then H1 by H2 is equal to T1 square by T2 square. The time of all of two objects are in the ratio 1 is to 2. So in the place T1 by T2 whole square. This ratio is given 1 is to 2, that is square, that is equal to 1 is to 4. So 1 is to 4 is the right answer. Option 3 is the right answer. Next go to 67th question. Two bodies are held separated by 9.8 meter vertically, one above the other. Right, my dear children, vertically one above the other. Suppose A body is here and B body is here. Their separation is 9.8 meter vertically. They are released simultaneously to fall freely under gravity. After 2 seconds, the distance between them, they fall freely. They fall freely. Suppose from A, this is A, it is falling freely. After 2 seconds, this is the distance traveled by A. Then after 2 seconds, this is the initial velocity of B. After 2 seconds, the B is here, suppose. Then what is the separation between them? The distance between them after 2 seconds. Calculate after 2 seconds the distance traveled by A. Then S equal to, in the place of U0, that is half G T square. So this is the distance traveled by A after 2 seconds, that is equal to 1 by 2 G, in the place of T, 2 into 2. So 2 gets cancelled, that is equal to 2G, that is equal to 2 into 9.8, that is 19.6 meter. Then for B also same, SB equal to half G, again 2 squared. So the distance traveled by B is also 19.6 meter. That means B traveled from here to here 19.6 meter, A traveled from here to here 19.6 meter. Again between A and B, because how much distance A travel, same distance B also travel after 2 seconds. That means the distance between them is again 9.8 meter. So option 3 is the right answer. So 67th one, option 3 is the right answer. 68th question. So from the position time graph for two particles A and B is shown below. Graph A and graph B are making 60 degrees and 30 degrees with the time axis. The ratio of velocities of VA is to VB is. Already we know very well, my dear children, slope of ST graph, that means displacement time graph, gives slope of displacement time graph gives velocity. And already we know very well, slope is equal to tan theta. Slope is equal to tan theta. So from this here, velocity of A by velocity of B is equal to tan. So A is making with x-axis, that means time axis 60 degrees, that is tan 60 by tan 30 degrees. Already we know very well tan 60 value. Tan 60 value is nothing but sin 60 by cos 60. That is equal to root 3 by 2, 1 by 2 gets cancelled. So tan 60 value is root 3. Next cos tan 30. Tan 30 is 1 by root 3. So from this root 3 by 1 by root 3, this root 3 comes in numerator, root 3 into root 3. That is equal to 3. That is equal to 3 is to 1. 3 is to 1 is the right answer. So option B is the right answer. Next, 69th question. Look at the screen, my dear. Look at the screen. From the velocity time graph, it can be inferred that the object is. Here velocity time graph, see, with respect to time axis, velocity is not changing. If velocity is not changing means, my dear children, here velocity is constant. If velocity is constant, that type of motion is called uniform motion. So 69th one is option A is the right answer. 69 option A is the right answer. Next 70 question. This is very easy, my dear children. Area under VT graph represents a physical quantity which has the unit of. Already we know very well, my dear children. Suppose velocity time graph. Suppose graph is like this. See, this is the area under velocity time graph. So area under velocity time graph gives displacement. Displacement. So what is the SI unit of displacement? The SI unit of displacement is meter. So option B is the right answer. 70. Option B is the right answer. Next go to 71. Right. Four cars A, B, C and D are moving on a level road. Their distance versus time graphs are shown in figure. Choose the correct statement. Already we know very well slope of distance time graph. Slope of distance time graph gives speed. Speed. If slope is greater, that means, my dear, very well, we know very well slope of distance is speed. If slope increases, speed also increases. Speed also increases. Observe the slopes. Here, observe the slopes. So car C slope is greater. So car C is the faster. Car C is the faster one. So here option car C is not there. Now observe car B. Car B is the slowest one. So option B is the right answer. Car B is the slowest one. Slope of ST graph gives speed. If greater the slope, greater is the speed. So here actually slope of car C is greater. So car C is faster. But here option is not there. So go to slowest one. So car B is the slowest one. Next 72. So look at the screen, my dear children. 72. Which of the following figure represents uniform motion of a moving object correctly? So a distance time graph is given. So my dear children, here distance time graph is given. So distance time graph, in distance time graph, uniform motion. Uniform motion means speed should be constant. Speed should be constant. Speed should be constant. That means in distance time graph, speed should be constant means, already we know very well, slope of distance time graph gives speed. Speed. If slope is constant, if slope is constant, if slope is constant, speed is also constant. That means, my dear children, here theta should be constant. Theta should be constant means the graph should be straight line. So 72, option 1 is the right answer. Option 1 is the right answer. Next here 73 question. Slope of velocity time graph gives. Slope of velocity time graph gives. So velocity time. Already we know very well slope of velocity time graph. Slope of velocity time graph gives acceleration. Acceleration, my dear children. Already we know very well slope is equal to rate of change of y with respect to x. Here rate of change of in and y axis, that is v is there, on x axis that is t. So slope is equal to nothing but rate of change of velocity with respect to time, that is equal to acceleration. So 73, option C is the right answer. Next here 74. 74 question. So look at the screen. Look at the screen, my dear. Right. The velocity time graph shows the motion of a cyclist, its acceleration and the distance covered by a cyclist in 15 seconds are respectively. In 15 seconds are respectively. Here first calculate acceleration. If you observe the graph, velocity time graph, here in velocity time graph, the graph is parallel to time axis. If graph is parallel to time axis with respect to time, the y value is not changing. That means velocity is not changing. That means your cyclist is moving with a constant velocity. Constant velocity means its acceleration is equal to 0. Acceleration equal to 0. Next, calculate distance covered by cyclist in 15 seconds. In velocity time graph, area under velocity time graph gives distance. Distance. So find here area up to 15 seconds. Up to 15 seconds. It is in the form of rectangle. All we know very well, area of rectangle is equal to length into breadth. In the place of length here time, that is 15 seconds. In the place of breadth, that is velocity, that is equal to after 15 seconds, that is velocity, breadth is nothing but 20 meter per second. Second gets cancelled, 20 into 50, that is 300 meter. Acceleration is 0 and distance is 300 meter. So option D is the right answer. Option D is the right answer. Next, my dear children, 75th question. A particle moves according to given velocity time graph. The ratio of distance traveled in last 2 seconds to the total distance traveled is in last 2 seconds. That means this is the last 2 seconds. Suppose this is S1. Already we know very well area under velocity time graph. Area under velocity time graph gives distance. So calculate area here. So here S1 is equal to area. This area is in the form of triangle. So area of S1 is equal to nothing but area of triangle. Area of triangle means that is half into base into height. So here half base. Base is 2 seconds. Height is 10 meter per second. 2 gets cancelled. Second and gets cancelled. That is equal to 10 meter. Then calculate total distance. Total distance with this distance and this distance. So this distance is similar to this one. So here this distance is also 10 meter. Then calculate this distance. This is in the form of rectangle. Already we know very well area of rectangle is equal to length into breadth. That is here this length is 3 seconds. That means 3 to 5, 3 minus 5 means 5 seconds minus 3 seconds, that is 2 seconds, into breadth is 10 meter per second. Second gets cancelled, that is equal to 20 meter. So this is 20 meter and this is 10 meter. Total distance, suppose that is S2. Total distance equal 10 meter plus 20 meter plus 10 meter equal to 40 meter. Then the ratio of distance traveled last 2 seconds to the total distance, that is S1 by S2. S1 is 10 meter, S2 is 40 meter. Meter gets cancelled, 0 gets cancelled. 1 is, that is 1 is to 4. So 1 is to 4 is the right answer. Option A is the right answer. Next, go to 76th question. Here 76th question. The velocity of a body increases for some time, then remains constant and then decreases until it comes to rest. When velocity is plotted against time, so the figure obtained is. So in the first case, here first graph, velocity time graph. So first one, the velocity of a body increases for some time. That means velocity is directly proportional to time. That means this is the first one. Then it remains constant. It remains constant. That means velocity should be constant. So constant means it should be parallel to time axis. That is 2. Then decrease until it comes to rest. Decrease until it comes to rest with this one. So this graph is obtained like a trapezium. So option 2 is the right answer. 76, option 2 is the right answer. Next, go to 77th one. The area under the acceleration time graph represents. Acceleration time graph represents. So my dear children, here this is acceleration, this is time. Suppose draw any one type graph. Suppose the graph. So this is the area under the graph. Already we know very well area under. Area means nothing but multiplication. That means y-axis into x-axis. So area under acceleration time graph gives nothing but change in velocity. Change in velocity. Change in velocity. Why? Because acceleration equal to rate of change of velocity. So acceleration into time means that is equal to change in velocity. So the area under acceleration time graph represents change in velocity. So option 1 is the right answer. Next, go to 78th question. Right. When a graph between one quantity versus another results in a straight line with a positive slope, the quantities are. The quantities are. So my dear children, we know very well. So look at the screen. Suppose draw a graph between velocity and time. So positive slope means here the theta should be less than 90 degrees. So this is a positive slope. So here velocity is directly proportional to time or not. That means with the time the velocity is increasing. Velocity is increasing. So when a graph between one quantity or another results in a straight line with a positive slope means those two quantities are directly proportional to each other. So option 1 is the right answer. Next, go to 79th question. Here 79th question. Velocity time graph. Velocity time graph for a moving object is shown in the figure. Total displacement of the body during the time interval when there is non-zero acceleration and retardation is. Here in velocity time graph, observe here velocity is, the graph is parallel to time axis. Parallel to time axis means here acceleration is equal to 0. Here also velocity time graph, in velocity time graph the graph is parallel to time axis, that means constant velocity. Here also acceleration is 0. So here and here in these two cases only, this is the first case, the second case, here only the acceleration is non-zero and retardation is non-zero. So find the displacement in these two cases. So observe the, already we know very well, observe the graph carefully. So you have to calculate displacement. Already we know very well, area under VT graph gives displacement. Displacement. So in the first case, calculate the displacement. Displacement equal to area of triangle plus area of rectangle. So area of triangle means half into base into height. Area of rectangle means length into breadth. So half base, here to here the base is 20 seconds and 30 seconds. The difference is 10 seconds into height 0 to here height is height from here to here. Actually this is the height. This is the height. So 1 second 4 seconds. So 1 second 4 seconds. Here this is the height 4 and here 1. That means 4 minus 1. That is 3 meter per second. Second gets cancelled. 2 1 2 5. That is equal to 15 meter plus length into breadth. Length 10 seconds 30 seconds. The difference is 10 seconds. Breadth. This is the breadth. This is the breadth. 0 to 1. 1 minus 0. That is 1 meter per second. That gets cancelled. 15 meter per second. That is equal to 25 meter. So this is 25 meter and this is also 25 meter. The total displacement is 25 meter plus 25 meter, that is 50 meter. So option B is the right answer. 50 meter is the right answer. 80 question. So look at the screen. Figures 1 and 2 below show the displacement time graphs of two particles moving along the x-axis. We can say that, you know very well, in displacement time graph, if graph is straight, body is moving with uniform motion. Uniform motion means constant velocity. But here graph is bending. That means it looks like a curve. It looks like a curve means here velocity is variable. Velocity is variable. Velocity is variable means this type of motion is called non-uniform motion. So the two graphs depict that the particles are moving with non-uniform motion. But look at the graph 1. Here my dear children, here theta is increasing. Here theta is increasing. If theta is increasing means, already we know very well, theta is increasing means tan theta is increasing. If tan theta is increasing means slope is increasing. Already we know very well, in displacement time graph slope gives velocity. If slope increases means velocity increases. But velocity increases uniformly. That means equal changes in velocity in equal intervals of time. That means particle is having uniformly accelerated motion. Uniformly accelerated motion. Here also look at the graph 2. The graph is curve, looks like a curve. When the graph is in displacement time graph, the graph is curve. The body is moving with non-uniform motion. Non-uniform motion means velocity is variable. Here velocity is variable. Velocity is variable means that is non-uniform motion. Non-uniform motion means definitely there should be an acceleration. But here, my dear children, here theta is decreasing. If theta is decreasing means tan theta is decreasing. If tan theta is decreasing means slope is decreasing. That means velocity is decreasing. That other thing, but speed is decreasing. That means equal decrease in velocity in equal intervals of time. That is, the body is, that means body is moving with uniformly retarded motion. So option 3 is the right answer. Next, go to 81st question. So look at the screen. BC represents a body moving with. We know very well this is a displacement time graph. In displacement time graph, the graph is straight. The graph is straight. The body is moving with uniform motion. Uniform motion means that velocity is constant. Velocity is constant. That means uniform velocity. And here in displacement time graph, the graph is parallel to time axis. Parallel to time axis means here the body is at rest. But observe BC. BC, that means BC here the graph is straight line. The graph is straight line means body is moving with uniform velocity only. Uniform velocity only. But here body is moving away from the origin. But here body is moving towards the origin. Towards the origin means the body is backward with uniform velocity. Option 1 is the right answer. Next, go to 82nd question. Right, 82nd question. The velocity time graph for a particle moving along x-axis is shown in the figure. The corresponding displacement time graph is correctly shown by. So observe here velocity time graph. Velocity time graph, the graph is a straight line. Graph is a straight line. In velocity time graph, the graph is a straight line. Body is moving with uniform acceleration. Uniform acceleration. If acceleration for this graph, displacement time graph. For displacement time graph, the graph is curved because acceleration means non-uniform motion. For non-uniform motion, displacement time graph, the graph is curved but is bending towards the positive y-axis. Positive y-axis. Positive y-axis. Next here, velocity time graph, the graph is parallel to time axis. If the graph is parallel to time axis means velocity is constant. Velocity is constant. For this in a displacement time graph, velocity is constant means velocity is constant and is a negative axis. Negative axis means theta should be greater than 90 degrees. The graph is like this because in this situation here theta is greater than 90 degrees, then velocity is negative. So for this, the graph is like this. So option 4 is the right answer. Combination of these two gives option 4. So option 4 is the right answer. Next, go to 83 question. Which of the following graphs would probably show the velocity plotted against time graph for a body whose acceleration time graph is shown in the figure? Acceleration time graph. Here this is acceleration time graph. Here first one, observe here. Here acceleration. Here acceleration time graph. In acceleration time graph, the graph is parallel to time axis. If the graph is parallel to time axis, acceleration is constant. Acceleration is constant. If acceleration is constant, for velocity time graph, it should be a straight line. It should be a straight line. Next here, the acceleration here the acceleration is 0. For this, in velocity time graph, the acceleration 0 means velocity should be constant. Velocity should be constant means the graph is parallel to time axis. Then again here the acceleration constant. Again for velocity time graph, the graph is like this. So the combination of all these three gives option 1. So option 1 is the right answer. Next, 84th one. The velocity time graph of a body falling from rest under gravity and rebounding from a solid surface is represented by which of the following graphs? So velocity time graph here from rest. Here initial velocity is 0 while it is coming down its velocity increases. Velocity increase. That means velocity is directly proportional to time. Velocity is directly proportional to time means the graph is like this because here the body is under gravity means it is falling with uniform acceleration. Uniform acceleration. For uniform acceleration, in velocity time graph, the graph is a straight line. The graph is a straight line. After reaching the ground, it has a maximum speed. It has maximum speed. But after reaching the ground, it is rebounding. It is rebounding means what happens? It is going up. It is going up. When it is going up, its speed decreases. After reaching maximum height, its speed equal to 0. Its speed equal to 0. But in reverse direction, this is taken as positive. This should be negative. That means initial value should be greater. Initial value should be greater. But it is with respect to time. With respect to time, its speed decreases. Finally 0. So option 1 is the right answer. Next go to 85th question. The figure shows the displacement time graph of a particle moving on a straight line path. So what is the average velocity of the particle? What is the average velocity of the particle after 10 seconds? Already we know very well average velocity is equal to total displacement. Total displacement by total time taken. Total displacement by total time taken. Total time taken. Total displacement by total time taken. So consider this is the initial position. This is the final position. So calculate displacement. Already we know very well displacement means final position minus initial position. Final position minus initial position. Here final position. This is the final position. This is the final position. So y-axis 0 to 40. That is the 40 meter is the final position. Final by 40 meter minus initial position, that is 60 meter. 60 meter, that is equal to minus 20 meter. So total displacement is 20 meter and total time taken is 0 to 10, that is 10 seconds. That is equal to minus 20 meter by 10 seconds, that is equal to minus 2 meter per second. So this is the average velocity. But the magnitude of average velocity is equal to, if only magnitude is there, that is equal to 2 meter per second. So 2 meter per second is the right answer. Option 1 is the right answer.